In this video, we want to look at finding the values for all 6 trigonometric functions if you're given an angle that's in standard position and you know a point that the terminal side goes through. So we've got 4 examples here that we want to go through, starting with number 1. So the first one here is we have a point given by 3, -4, and we want to find all of the trig values. So the best way to do this is to just draw a quick sketch of this. So we have the ordered pair 3, -4, so that is 3 to the right, 4 down, put a point right there, and go ahead and label that too. So that's 3, -4. And we're looking at the angle that's formed going from the origin and going through that point. It's always going to look like that, okay? Starting at the origin and going through that point. And then we drop that perpendicular to the x-axis. We mentioned this in the last video, talking about it again here, which means you always bring it up to the x-axis and you form that right angle. And your theta is going to be the angle that's formed from that terminal side and your x-axis. All right, so let's find all 6 trigonometric function values. So let's start with sine. Well, sine is going to be opposite over hypotenuse, so we should probably label this triangle first, right? Now, since we have the ordered pair 3, -4, that means that your x value is 3, your y value is -4, and if we do the Pythagorean theorem, we can find our value for r. So that's going to be taking the square root of the sum of 3 squared and -4 squared. All right, so that gives me 9 plus 16, which is the square root of 25, and that equals 5, which shouldn't be a surprise to us because in the last video we talked about Pythagorean triples, and 3, 4, 5 was one of the first ones we talked about. Again, if it is going to be a Pythagorean triple of 3, 4, 5, the 5 would have to be for the hypotenuse. So always be mindful of that. All right. So that guy is going to be 5. So remember, sine is supposed to be, well, the way we define this, we did 2 different ways. We said y over r. So that means the y value is -4 over my r value of 5. And yes, we can have negative values here. And we'll talk more about that as we go on. And one of the things to keep in mind, though, is in a very basic sense, sine is going to be connected to how far above or below the x-axis you are, okay? Especially when we start talking about the unit circle. So if your y value is above, sine is going to be positive. If it's below, sine value is going to be negative. Cosine is connected with your x value. So when you're in the, say, 1st or 4th quadrant, it's positive. When you're in quadrants 2 or 3, cosine is going to be negative. Again, keep in mind that we talked about how this is the opposite over the hypotenuse. So whether you look at y over r, opposite over hypotenuse, it's going to be the same thing. For cosine, we said this was going to be x over r. It's that ratio. So the x here is +3, r is +5. So that's it. And again, we said that this was adjacent over hypotenuse. So we can see that this 3 is the adjacent side, and of course 5 is the length of the hypotenuse. And now let's look at the tangent. Tangent is y over x. My y value is -4, and x is +3. We can connect this by saying this was opposite over adjacent. So there's the whole SOHCAHTOA, all coming from the diagram. Now, for the other trigonometric functions, I don't want to say it's cheating, but if you know the connections, if you paid attention to what I showed you in the last video, then we can easily get the rest of these. So let me just erase this work real quick. Where do you know that r is 5? So let me do cosecant first. I know it's kind of gauche to do it that way, but here's the thing. Cosecant is the reciprocal of the sine. So you can look at this as 1 over sine or you can look at this as r over y. Whichever way you look at this, it's still going to give you the same thing, which is going to be negative 5 over 4. So you can rebuild this, or you can remember that cosecant is the reciprocal of sine and just flip it over. In much the same way, when we do the secant is the reciprocal of cosine. Or, if you want to, think of this as r over x. Okay. Now I'm going to kind of stop writing that stuff, and we're just going to keep building on the fact that secant is the reciprocal of cosine. I'm not typically going to write 1 over cosine. I'm just going to look at cosine, which is 3 over 5. I'm going to flip it. So we end up with 5 over 3. And then we have cotangent is the last guy to get. And he, like we talked about before, he is the reciprocal of tangent. In other words, he is x over y, which gives us negative 3 over 4. So that's how we would find the 6 trigonometric function values if all we have is this point that we're going to be going through. Okay, so let's look at number 2. So in number 2, we are going through the ordered pair negative 12, negative 5. So in all of these, draw the picture. That is the most helpful thing that you can do to really understand what's going on. So the order pair negative 12, negative 5 is something like this. So here's negative 12 and down 5, so it's going to look like that. Again, we're not going for exactness here. I just want to get an idea about where I am. Drop that perpendicular to the x-axis like so. And this is the theta that I'm talking about. All right, so this was my x, this is my y. Put that in the diagram. I know it seems kind of weird to have a triangle and us putting negative values here, but it's okay. It's just really more of a location for us, okay? So x is negative 12, y is negative 5, and we just need to find the hypotenuse. Well, remember that there was the Pythagorean triple that went 5, 12, 13. So we can use the Pythagorean theorem, but we can also remember the fact that we have this Pythagorean triple and know that my r is going to be 13. My r or my hypotenuse, however you want to look at it. All right, so let's look at the sine. Sine is supposed to be opposite over hypotenuse. So the side that is opposite our theta is negative 5, and my hypotenuse is 13. So that's the so part. So ka, so that's C-A-H, that means adjacent over hypotenuse. The adjacent side is negative 12. Hypotenuse is 13. And then we have the tangent. So ka to us, that's O-A. That means opposite over adjacent. So the side opposite is negative 5. The side adjacent is negative 12. And of course, you want to make sure that you simplify. Negative divided by negative is positive. All right. So now we're going to find their reciprocals. So the reciprocal of sine is cosecant. So take the fraction that you see and turn it over. So that's negative 13 over 5. The reciprocal of cosine is secant, so we're going to flip that guy over. So that's negative 13 over 12. And then the cotangent is the reciprocal of tangent. So flipping that guy over, we have 12 over 5. Okay? Again, if you want to like completely rebuild this based on the forms that we had in the last video, you can do that. But I want you to understand the connection between sine and cosecant, how they are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. It will just save us a ton of time going forward. All right, let's look at number 3. So number 3, we're going through the ordered pair 7, 6. Again, draw a quick little diagram. X is 7, Y is 6, so something like this. Again, we drop the perpendicular. Okay, your angle must start at the origin. It has to. And then you go from there to and through the point that is given to us, in this case, 7, 6. Okay? And once we have that ordered pair, we can then start putting in and labeling the side lengths. So my X is 7, Y is 6. They're both positive because we see that in the ordered pair. They're both in quadrant 1, so both X and Y are going to be positive. Now to find the R value, to find the hypotenuse, we're going to have to use the Pythagorean theorem because there's not a nice triple that uses 6 and 7. All right, so I'm going to do 7 squared plus 6 squared. All right, 7 squared is 49, and 6 squared is 36. 49 plus 36 would give me 85. Now, normally I would try to reduce a radical. 85 breaks down to 5 and 17, and that doesn't get us anywhere. So we're just going to have to leave it like that. So let's mark that in the diagram, make sure it's nice and clear, and then do what we're supposed to do. So sine is supposed to be opposite over hypotenuse. So the side that is opposite our theta is 6, and the hypotenuse is the square root of 85. Now, my math lab is not going to allow you to leave an answer like this. Always rationalize your denominators. So the easy way to do that for this one is to multiply both the numerator and denominator times the square root of 85. And we end up with 6 square roots of 85 over 85. So rationalizing the denominator is just rewriting so that we don't have a radical in the denominator. That's it. And the more of these you do, the easier it is to figure it out. Cosine is supposed to be adjacent, which is 7, over the hypotenuse, another radical. And again, we're going to rationalize. And because 85 doesn't break down at all, we're just going to use that full-on radical. We get 7 square roots of 85 in the denominator. That gives me 85. I think finally we get an easy one with tangent. Tangent is opposite, 6 over adjacent, 7. Okay, thank goodness that one's done, right? But now let's get the other 3 trigonometric functions. Again, think about the reciprocals. So the reciprocal of sine is cosecant. Now I could take this guy right here and do the reciprocal. I don't really want to do that because if I do that, then I have to rationalize and it gets really messy. Instead, I want to back it up a little bit and look at what I have right here. If I were to take that starting value that I had and do the reciprocal, I end up with the square root of 85 over 6. And it doesn't need to be rationalized. It's just done. So cosine is connected to secant, and that's also going to be the reciprocal. But we can play the same trick that we did for cosecant and just take what you see right here. Before I rationalize the cosine, flip it over. We have the square root of 85 over 7. And then finally for the cotangent, we had 6 over 7 for the tangent. Cotangent is the reciprocal, so 7 over 6. Done and done. So find sine, cosine, tangent, and then remember the connection they have with their reciprocal components. And just turn things upside down. All right, one last problem. So if I have negative the square root of 3, comma the square root of 2. So this is maybe not the prettiest looking thing we've done. But again, draw the picture. So we have a negative x and a positive y. So it's going to be somewhere right about here. And we're going to drop that perpendicular like we've been doing. Again, drop it down to the x-axis. Here is my theta. Putting these values into my diagram, my x value is negative square root of 3. The y value is the square root of 2. We just need to find the r. We need to find that hypotenuse. So again, r is the square root, and we're going to take the square of x and the square of y. Oops, don't like the way that looks. So if I do the square root of 3 squared, that's a positive 3. The square root of 2 squared is just 2. So r is equal to the square root of 5. All right, so let's put that in the diagram like so. All right. Sine of theta is supposed to be opposite square root of 2 over the adjacent square root of 5. We run into the similar issue that we had in number 3, where we have radicals in the denominator, so we need to rationalize. So I don't really care what the numerator is, it's all about fixing that denominator. So if I multiply times the square root of 5, in the numerator we have the square root of 10, in the denominator we just have 5. And we're done. Nothing else I can do there. You're going to see something very similar to that when you do the cosine. Cosine is adjacent, so negative square root of 3 over the hypotenuse, which is the square root of 5. Again, we have to rationalize. And we let the denominator lead the way because that's the guy we're trying to fix. And we have the square root of 15 divided by 5. All right, let's see what tangent gets us. Tangent is opposite square root of 2 over adjacent, which is negative the square root of 3. So we'll put the negative out here in front like that. You don't want to leave a negative factor in the denominator. Just is not as nice as it could be. So the denominator in the way is the square root of 3. So let's rationalize that. We have negative. In the numerator, you get the square root of 6. In the denominator, you just get 3. Now, if you were to multiply that, you would have the square root of 9, which is, we're just getting 3. We are being very intentional about what we're doing so that we don't have a radical in the denominator. And in the numerators, as long as they are both square roots, you can multiply their radicands, so 2 times 3 is 6. When it comes to the other trig functions, it is going to be kind of messy. But let's start with the cosecant. So we got to flip the sign upside down. So that's going to be the square root of 5 over the square root of 2. Again, rationalize. So we have the square root of 10 divided by 2. Moving on to the reciprocal for cosine, which is the secant of theta. We still have a negative, so now it's the square root of 5 over the square root of 3. Rationalize using the square root of 3. We have negative square root of 15 divided by 3. And then we want to find the reciprocal of tangent, which is cotangent. So we're going to flip that guy over. So negative square root of 3 over the square root of 2. Rationalize. I'm telling you, the more of these you do, the easier it is. And there we go. We found all of the 6 trig function values for this angle that's being formed as that ray goes to the ordered pair negative square root of 3 and square root of 2. This one took longer than the others, and that was mainly because we had to worry about rationalizing denominators. So with practice and a little bit of time, you can see that's really not all that bad. You just have to be very careful about what you write, be very clear with your symbols, watch out for your signs, and make sure you do know how to rationalize correctly.